Do you think that data engineers are sort of averse or afraid to use an LLM to build data pipelines?
If you're not able to do this already, putting an LLM in place or an agent won't help you because you cannot even tell if it's doing the right job or not.
Making data pipelines with LLMs is really about the documentation.
Internally, we say the docs are like the lingua franca.
Do you think that a data engineer who's just, working in pipelines and infrastructure, can they just go become an AI engineer?
Data engineering is like critical to AI engineering because
Hey everyone, today I'm joined by Thierry Jean. He's a senior AI engineer, and I'm super excited to talk to him. Thierry has a great background. He has a wonderful story. We met each other at the Small Data Conference where he was explaining and showing dlthub and a lot about context engineering, vibe coding. We're going to get into that. We're going to talk about data pipelines, what we think an AI engineer even is. I just am ready to get into it. Thierry, how are you doing today?
Doing good. Thank you for having me.
Wonderful. Awesome. So, hey, listen, I took a quick look at your LinkedIn and I was kind of surprised. I was quite shocked by your background. And so I'm super interested to just know, how did you get to the role that you're in right now? Give us the background.
Yeah, cool. So right now, titles are very flexible where I'm at, but I'd say I'm a senior software engineer or a senior AI engineer at dlthub. And how did I get there? So I started coding while I was doing my bachelor in psychology and neurosciences. Really just of sheer interest for coding, started with Python. And at the time, through my studies, I realized that Python and machine learning was very important in neuroscience because you have a lot of high volume data, 2D, 3D, and even like 4D. So like brain imaging and also the time axis. And just the old like statistical methods that worked for decades were not adequate for the volume of data that you had. And so I spent more time coding, and I decided to not become a therapist. So I applied for a master. Initially, I was going to do a master's in the psychiatric sciences. And actually, like 1 or 2 weeks before the start of the first semester, I applied for computational medicine. It was a brand new program. I think it was the second semester. And essentially it's data science with health data. And we were a cohort of just 6 people. And so for 2 or 3 years, I did research on mental health and how it could be related to the different sensors and data that is produced by a smartphone. So you can think of GPS, Bluetooth, your activity of like unlocking the phone at night, like could be indicative of certain mental health status. And at that time, you have a lot of creative space when you are a graduate student. Very busy schedule, but you do have some time to think and read. And reading all of these machine learning paper, I realized a lot of them are hard to reproduce. A lot of assumptions are kind of hand wavy, like we think the data is like that, or it's clean, or there's a certain mean, and there's no questions about outliers. And I realized that there was a lot of excitement about ML, machine learning, but the tools or the way of doing things were not super scrutinized or like checked for quality all the time in the scientific papers I was reading. And that's when I started being more interested in ML ops, which was very trendy at the time, machine learning engineering. And through my graduate studies, I was able to take a look at all of the like new shiny tools that we had in data engineering, machine learning engineering. At the time, feature store was a very like trendy term. And that's also when I first started contributing to open source. Actually, I was building feature engineering, like features for the data I was exploring and using in my experiments. And I found this new Python library that was just released called Hamilton. And this was built in-house at Stitch Fix for time series feature engineering, and it was recently open sourced. And I really spent some time like writing in the community Slack. Eventually, I wrote a blog, contributed some issues and some code, and that was one of my first job after graduating, working at the company that took the lead for Hamilton development. The company was called DagWorks. And that really opened my eyes to how nice it is to work in open source. I gained a taste for good Python tools, I think. And providing a good developer experience. And something that like irks me when I'm using the tool, I can spend like 10 hours fixing it, and then thousands or maybe millions of users benefit from the improvements that I make. And it's a very like special feeling that you get, and you have interesting incentives, I think, in open source. And uh, in between those two things, also, I got the chance to be an instructor assistant for professional courses. I got to teach with experts in their domain for ML powered search, natural language processing with people from Hugging Face, and causal inference. And the people attending these online courses were all like people working at Fortune 500s, like big tech companies. And I got to develop some empathy for the things they have to deliver, the things they're accountable for. And I think all of these elements like shaped my career path, and like gave me a good background to empathize with the things people are trying to solve, but also be equipped to build the tools that could solve these problems. So spending almost 2 years at Dagworks, it was eventually acquired by Salesforce. And some of my colleagues are now leading Agentforce. We had another library called Burr. So Hamilton was data transformation, and Burr was for agents. And then agent was the new thing, and a lot of excitement. And after Dagworks was acquired, I joined DLT. So sometime earlier this year, I was already a DLT user. I'd built integrations between the transformation layer that Hamilton provides and the extract and load that DLT, the Python library that I work on currently, provides. And so I knew the team, I had contributed to open source. And again, it was a very organic match, me ending up there. And yeah, a lot of things happened this year. I'm excited to talk a bit more, but that's how I arrived at DLT.
Yeah, it's super interesting to kind of go from that computational medicine that I saw, and I was just thinking to myself, what's the jump look like there? Because it feels very statistically heavy. It feels really, like you said, probably a lot of like classical ML back in the day. That has seemingly disappeared out of the entire, lexicon of data in general. We just talk about AI and agents nowadays, which I think is sort of unfortunate. You went into open source, and I kind of wanted to just hit on that real quick, because DLT that you work on as well, there is an open source library, which I'm a huge fan of. What did you do to start getting into the open source contributions? What was that first contribution for you?
That's a good question. I actually contributed to a lot of libraries, like for very small things, like, okay, there's a mistake in the documentation, like some step-by-step instructions are actually, they're not working, or things like creating an example. Like I'm using your tool, and I contributed to OpenVINO, which is a project led by Intel for accelerating ML models on CPU. And I just submitted a notebook that's a tutorial for a certain task. And my first contribution, I think, was actually like making a blog post about Hamilton and like how I use it for my scientific research. And eventually I started contributing bigger features. I think it makes me happy that whenever I talk about open source, people are very curious and like seem genuinely interested in how they can contribute. My best advice is pick a tool that you use and identify things that you want to fix for yourself. Because even if the project is complex, if you have like a carrot at the end of the task, and you like it's self-satisfying, then you just learn the ropes and learn how to interact with people on GitHub, and you realize that people like want to help. Like it's good for like project maintainers love to have people that are involved and like contribute back.
Yeah, that's a really, really good advice. And, I hear the same thing from a lot of people. My first basically poll, my first PR was, I just updated some documentation, or I found a little bug. Just candidly, I myself, I've tried a couple times and gone through it, and I feel like there is now a huge swath of people all looking for that little documentation error. So they actually seem to be even harder to find. But I think that's really amazing. So DLT is a library, a data load tool. I'm just a big fan of it. If anyone's seen me on LinkedIn or read my Substack lately, I'm talking about DLT. It's just kind of what it is. I think that there's a great pain point that it's hitting, and I think we're in this new modern data stack. I think we're now in the modern data stack. There's new problems, there's new ways to solve them, and they aren't quite requiring the old tools that we had before. That being said, there is also dlthub, which is a product in itself that is sort of adjacent to the DLT library. What are you working on right now, and what problems are you solving with your work right now between DLT, the library, and dlthub?
Yeah. So DLT, I think to give a bit of an origin story, it started as not a passion project, but like trying to solve a concrete problem that like consultant in data engineering were facing. Like some of the co-founders have been like involved in like consulting and doing data engineering, like doing the groundwork on like as part of their own career. And there was clearly a gap in the Python ecosystem. Python, it's interesting to look back, but it was not as huge as it is today, like 3 years ago, 5 years ago, 10 years ago. But with machine learning and AI, like Python is gaining a lot of traction. And it was still like a common and recurring problem to be able to load data from somewhere and push it to tables. Tables meaning like you have columns, you have rows. We think of SQL, we think of Parquet files, and but data that comes into a table can be all sorts of things. It can be like PDF that you extract text from. It can be like a JSON blob that has a bunch of like nested objects. And so DLT was built to do this extract and load. And me, where do I come in? Like DLT, I think right now is the most popular Python library to do extract and load. And when I say this, I mean DLT gives you the code, gives you the toolbox to build your own connector, maintain your own connector. There are other like Python offering for EL, but your code doesn't like give you ownership of the pipeline in the same like deep and meaningful way that DLT provides. And what I'm working on right now on DLT, mainly like improving the Arrow connector right now. I think it's something that has gained a lot of traction. You have a lot of systems that accept Arrow data natively, but a lot of systems have data that is messy. If we're able to make this messy data into Arrow and then load the Arrow table as is, we're more efficient. And the next big thing, I think, is when you have Arrow in the source system and Arrow in the destination, and you're able to move things from one end to another without even like converting it into something else, then Arrow, it will be more like much more efficient. This means like performance improvements. It means cost reduction. Also like reliability. Like if people have experienced like type changes from source to destination, like it's a bane of being a data engineer. And yeah, just maybe to explain Arrow, if people are not familiar, it's a specification of how like columnar data should be structured and like the types that it can accept. And it's becoming a growing standard, and it's simplifying a lot of the tools people are building, because if they support Arrow, then they can easily integrate with many other systems. And that's for DLT.
Yeah,
go ahead.
Yeah. I was going to say Arrow's just one of my favorite technologies, just in general. And when I saw that too, I saw that DLT is kind of moving over to the Arrow connector, and I was just like, great, like that's awesome. It's kind of everywhere, but it hasn't quite had its inflection point. I think it's really, really close to where everyone's going to just realize, and I know that was ultimately the point of the project, is to get everyone to say, no, actually, this is how we should take columnar data from one thing to the other. That's it. And so, yeah, I thought that was really, really, really cool. Yeah, was there anything else you wanted to add on top of that?
No, but I think Arrow is like something worth looking into if you're not aware of what Arrow is, like for the viewers, for people listening. And yeah, I think it's interesting to see like Arrow is something open source. Like it's something managed by a committee. It's like there's obviously a lot of enterprises that have interest in the project, but the fact that it's open source is what makes this standard viable. And it's what makes it sustainable, what makes it adaptive. Like to be like really in the weed, Arrow is not often people associate Arrow with parquet, like a certain type of files, but actually Arrow is more flexible than that. There's a lot of file formats that can write Arrow data, and we're seeing a lot of posts about this, and a lot of companies are finding things that are optimal for ML, that are optimal for AI, generative AI, and Arrow is still like super relevant. Like it's not something that's a fad, it's not something that will go away. And I think like it will be a lasting technology because it's open source.
I totally agree. And you brought up a point about the way it's finding use cases in other places, like AI, for example. I've thought a lot about how a technology like Arrow of just bringing in information and data in a different way than, say, just tabular data, how that could be efficient for, we'll say, agents to run, the tool calls to happen within an LLM. That actually moves to the broader discussion of engineering those types of systems, those AI systems, and that sort of leads to this this idea of the AI engineer. And I wanted to talk to you about that. You said that your title is sort of loose. It sounds like, maybe it's like, yes, I'm an AI engineer, but if I really was to ask you what that means, you'd be like, well, I touch everything. That could be the case. But the title of AI engineer, I saw it try to get, I basically saw data engineers trying to get turned into AI engineers, but then I feel like what I am actually seeing is that it is becoming its own discipline and its own way. What's your thought on the title itself of AI engineer? What do you think an AI engineer does or should be doing? And how does that relate to what you're doing?
Yeah, I guess I will answer the questions in reverse. So maybe like what I'm doing, and then how maybe it's more general. We're working on dlthub, like our premium offering. And in short, DLT is an open source library. It's Apache 2 license. It's free. It will remain that way. But we want to provide a more complete solution for enterprise where they can run their DLT pipeline and also have like the compute, the storage, and have AI next to their system. And because DLT is just code, the AI, and we'll define AI right after, but the AI can understand that Python code, and we provided the tools to understand the data, understand the logs of your pipelines that run, and the entire state of your system. And I think that's what the future will look like. We will have like I'll call them like systems, agents, or like pieces of code that run somewhere that are proactive in and can react to like events and things that happen in your like entire system, not just someone opening an issue on GitHub, but really like my pipeline failed. The fact that it failed like triggers something that's investigative and like it tries to find a solution. Like that would be what I think is like, what is AI looking like in the next maybe 5 years, 10 years? It's always hard to estimate these things, but we're building it right now. And what is AI engineering and why it's different from data engineering and let's say ML engineering, classical ML? I think it all goes back to what a large language model is, an LLM. If in a very reductive explanation, it's a text in, text out machine, but there's a lot of magic happening in this machine. And the only thing that I can do, given that I don't have 1,000 of GPUs and I'm not training my own model, the only thing I can do with an LLM is change the input. And the input is a string, right? It's a piece of text. And all I can do as a user of the LLM is change the input that I give to this big magic box that outputs strings. And also, how do I handle the strings that it gives out? Like this might be content that is harmful. It can be code that is harmful. It can be code that is gibberish. It can be completely irrelevant to the task. And there's, I think, different sets of problem, like on the upstream side, like what do you put in the machine and what you get outside of the machine. I think it's a like set of problems that are difficult and deserve like their own title, I'd say. But we're also seeing a lot of things that are the same as they were with ML and like doing experimentation and doing evaluation and having a training loop and like the type of deployments where you have something in a sandbox that you can try and test, and then when you push it to production, it can look very different, and you need to have safeguards, and you have adversarial settings where people are trying to trick your machine, and like it was interesting to come from maybe the earlier wave of machine learning because you see a lot of problems again, but with a different taste. And we like having this background and seeing what's the same, what's different is very helpful, I think.
Yeah, I think what's fascinating about the current state of what I would consider AI engineering, you did a great job of that. I aligned complete with that. After I learned about more about what the LM actually is, and then ultimately, honestly, what an agent is, which I think is misunderstood. It's software that is wrapping around the LM essentially and is parsing the responses from the LLM, looking for certain tags. Like each model has its own tags in its output, right? ChatGPT has them, Claude has them. But the agent is parsing and looking for things like tool calls. Like the LM thinks you should use this function. It will then take that and then it will essentially run a function to go run that function, subsequently. And then it'll return it back as an input back to the LM. It creates these loops, right? And that's obviously a lot more rudimentary than what is actually happening there. But that mental model, it sort of broke my brain because I realized, oh, that's the system that you're engineering. So the agent is actually the really hard part. Right now, these foundation models, like you said, we don't have any control over them except what the input is and then what we do fundamentally with the output, right? And then how we send it back in. I think that is really, really, that suddenly does feel more like how machine learning does look. We are now sort of something that's been trained, but we're kind of in this validation and evaluation stage where we're putting information back into it. So I did appreciate the way you said it has a different flavor of it. In ML ops, especially classical ML ops was about trying to keep track of model drift, for example. We would talk about it all the time. How does model drift look in a non-deterministic machine like an LLM? Do you think you can even keep track of that?
Yeah, so for machine learning, like traditional ML, as you described, like when we talk about model drift, I won't give a course on ML because we could spend another hour on that. But essentially, you have a machine that, like, let's say, outputs a class, so like a 0 or 1, or maybe it's a regressor and it has a continuous output, it gives a number. You give numbers in, you get numbers out. But the difference with previously on classical ML, you would train these models often. Usually you were like a lot of problems were solved by just retraining the model, retraining the model with more data. With LLMs, because of the cost that they require, this might change in the future. I won't make predictions on that, but because of their cost, you train models less often. So you have a certain guarantee of, okay, this version of Claude or version of GPT is stable. Like once it's released, it's the same. But I've heard stories from founders, from people using LLMs actively that, hey, we got the newer version, the smarter version, the machine, the LLM that does better on benchmark. But on my specific use case, there were some regressions or some things that change in behavior. Because if you think about, you ask the weather to the LLM, it's not something it can answer very well. But if you give it a text in, it will give you a text out. And there's even some randomness there. But if you give it a text in, you give in a text out, it's pretty easy to have expectation of what the text out should be. But once you create a loop, I see it as like a trajectory, like it deviates, it drifts. Like the more turns in a conversation, the like crazier the LLM response can be. And this is where like you need evals in place. You need like, if you have a workflow that's, for example, building pipelines or that is answering customer conversations, you cannot just assume like, I will just give a user input and check the output and see if this is safe. It's like, no, you need to like have tests or have evaluation about like, what if the user like spends 30 turns of conversation, like pushing the LLM towards like unsafe behavior. And it's not an easy problem to solve.
It's not. And so given that, do you think that a data engineer who's just, working in pipelines and infrastructure, can they just go become an AI engineer?
I think data engineering is like critical to AI engineering because even if you're not building the agent, even if you're not like building this loop and these eval system, you're the person like usually accountable for getting the text in. Like probably you have, maybe for you it's a Excel sheet, maybe those are PDFs, maybe there are comments online, reviews on your product, but the data engineer is responsible for providing like accurate data, fresh data, also doing maybe some live pre-processing or some application specific pre-processing of having the data in the correct format. And I think it's a very simple problem to state, but I don't hear it often enough, I think, but just the idea of like, okay, I have a JSON object, like it's a dictionary, like it has keys, it has values, but how do I represent that as a string? Like what's the optimal way to represent it as a string for the LLM to understand it and do the thing I want the LLM to do? And I think that's like the sort of things that data engineers are already doing. If it's valuable to them for different, like maybe political reason within the organization or for career reasons to become an AI engineer, like you're doing AI engineering already, like you deserve the title.
That's awesome. And I think then, do you think that building actually agents, or building the agents themselves, does that fall under software engineering more than it does, say, data engineering? Or so I guess the sub question is are software engineers also AI engineers if they want to be as well?
Yeah, I guess everyone's biased by their background. I think the most interesting thing that happened in the whole like data ecosystem is that you have a lot of people that weren't necessarily doing ML or doing data science at all that are interested in agents. Like to me, the biggest example of that is agent and LLMs have a lot of traction in the world of TypeScript and like JavaScript. Those are not people that necessarily were doing PyTorch model or XGBoost or like building classifiers, but they were people building applications. They were building things that they were serving like on smartphones or on websites and that were interacting with end users. And because the LLM there's still some magic to it and it's like a very powerful thing. Sometimes what you need is someone that can do good front end and just call OpenAI, right? But as the applications grow more complex, these people are evolving into more like AI engineers, but they come from front end. But then you have people that are data engineers that become AI engineer. You have people that are ML engineer, ML ops, like serving infrastructure that can have low latency and make predictions. And they're also AI engineers. So to me, is it software engineering? I think it is. But from my background, I see a lot of similarities with the ML and the data science and like, you measure things, you have hypothesis. Is this an improvement? Is it a meaningful improvement? Can you reliably reproduce a certain behavior? So I see it with a very like scientific, statistical lens, I think.
Yeah, I like that. And I think that's why it's a viable title, at least for now, because if you want to come from a software perspective, you probably have to skill up on some other things. And if you're coming from purely maybe a statistical ML data science perspective, you're going to have to skill up on another side of things, like more traditional coding in terms of production level code and things like that. That always seems to be, even with ML ops, I felt like that's what happened as well. You had software engineers trying to do it, and you had data science people trying to do it, and both of them sort of had to get better at in new things. So I think that's great.
The joke would be that like probably the people doing front end are the best at Git. So like that's already a pretty like strong skill to have when you're building software and complex things with LLMs. And yeah.
I know. I need to go just make my $1 million course, which is just 2 minutes to train data people how to use Git. And I think just everyone would sign up for that. I really need to get on that. Okay, so I wanted to keep on the topic of AI and data engineering and kind of data pipelines in general. So there is the promise, the Anthropics of the world claiming that, Claude Code is going to be writing 90% of code. Obviously, the 2 months where that was claimed it was going to happen have come and gone. The goalpost keeps getting moved. But the value of these models are there. And I think the consistency is improving. The hallucinations, as we call them, are reducing. But moreover, I think what we're learning is the skill set to work with these probabilistic machines better. I myself, I've built a bunch of little, hacks or skills or, rules of thumb that I use to, quite frankly, just get consistent results from what I want. DLT as a library, I found to be extremely good at responding to basically an LLM working with it. And one of that is the documentation is really good. Always want to pass that context. You were showing this at the small data conference we were at. You were talking about actually passing context in Cursor. And Thierry, I meant to tell you, I looked around and I just saw all these engineers like writing that down. And I was quite frankly kind of blown away by that because I just thought that was a given. Maybe I'm just always around the corner working on this stuff more. And maybe the reality is people just haven't had time to really get into the nitty gritty of how you make this work better for your code. But all I'll see on LinkedIn is the meme that, everything breaks. It's all hallucinations. It can't work. Even I myself, I had that question when it was first, coming out is how do you build a data pipeline with a probabilistic machine? And I think I had just a lot of naivete with context windows in general too and how they worked. So my question to you is, should we even use an LLM to build data pipelines? Do you think that data engineers are sort of averse or afraid to use an LLM to build data pipelines? So the better question first is, should we even do it?
Yeah, I think you said a lot of things that made me want to jump in. I'll take maybe like a more like business centric perspective first. Like people, I think there's a real like sentiment about like AI. Will it replace me? Will it make my job simpler, harder? And I think it can create some aversion to even interacting with LLMs. And at this moment, I think it's the best time to learn. Like things that are like greenfield, everyone's figuring it out. And what I've seen, at least, like being in open source and Python, you see a lot of new projects. Like people are able to just do a lot more by themselves, and like also just maintain a repository. And like you see projects that like have a significant amount of commits by Claude. So like the Claude code can like write comments for you, and I think that's meaningful. Like there's clearly something happening, like in software in general, and it's because LLMs can produce code, and this code works. It produces the output we expected. You can write tests, and it behaves correctly. And yeah, that's something I think that will be consistent, and like it has some real impact. Then for data engineering, which people often think as more complex than the just like software or like a deterministic system. And I think it is because you have two sets of problem, I think. And those are like the things I work on like actively right now. So I'm like very passionate about this, but you have the code. So let's say I want to write a data pipeline, like for any library, not specific to DLT, you just want to write a data pipeline. It's one thing to have code that runs, but it's another thing to say that the data is correct. Correct data is very specific to your business or your use case or like the practical implications of your data. It can mean like it has the right shape, it has the right data types, it has the volume you would expect. Like you expected to have thousands of rows, not tens of rows. And this correctness is hard to encode into text. Like you cannot just say like, LLM, make sure the pipeline only produces between 10 and 50,000 rows per day. You need tools that, like, when I say tools, I mean like you need Python code to validate what your data looks like after you run the pipeline. This would fall under maybe like data quality metrics or data quality checks. Those are two things I'm like actively working on right now at DLT and dlthub. So about writing pipelines with LLMs, the challenge is it's easy to get relatively easy to get working code because you can like dump it the full documentation for DLT or the full documentation for polars or any of the Python libraries, and it will do a decent job at writing code, and you can run it. If it runs, it works. But then checking if the data is correct is difficult. And this is already what's difficult for humans and data engineers without LLMs, right? And it's interesting to see like what you solve for humans like doing their day-to-day job. So better dashboards that for data quality. I think like the MCP server is cool because I can just ask in my chat window, like, was the data loaded on Monday? And you can have like accurate and factual information. I did not introduce the concept of MCP server, but just think of it as like it's actually looking at your data, running code to check if the data is there. And producing these tools for humans are also helpful in the broader, like building things with LLM, because the human can review the LLM's work. But if you don't have these things in place to check what your data looks like, make sure the schema doesn't break, make sure that you have a certain volume of data, if you're not able to do this already, putting an LLM in place or an agent won't help you, because you cannot even tell if it's doing the right job or not. And that's what's exciting right now, because we've been building DLT for like 3+ years, and we were already solving these problems. So with the agents, like the timing just so happened, and we knew LLMs were going to be a big thing, but right now it's everything we solve for humans is also useful for LLMs and humans using LLMs.
Yeah, that's a really good point too, because I think what is maybe getting missed in the conversation is there is, in a normal distribution, you've got these two extremes happening. And on each of those sides, they're saying, it'll write all of the code. Your job is useless. The other side is, it can't write any of the code. I'm not going to touch and use it at all. And then probably in general, what the majority of people are going to do is, I'm going to use it to do the boilerplate, the things I don't really want to do, or the things I don't find as interesting anymore. And what my new skill is, I now evaluate that output. And I have to know code to do that. And that there is a certain problem to that, right? Like you kind of need to go learn code still so you can evaluate properly, but maybe that will eventually get worked out. I don't know. But all that being said is, there is a level of evaluation that is now in the skill set with data engineering when we think about an LLM being involved. But ultimately, it is about that output. Because does it matter what the code is? I say that loosely, but does it really matter what the code is if the output is correct and it runs that, and that's how it runs each time? Like, this LLM's got to make this code. The pipeline ends up with what we believe is correct. We're just going to call it and we're going to move on. I think I've just built a data pipeline with an LLM. And I'm saying this because I have, like, this is it. I use DLT, but I have a complete checklist that I go through of how I work with DLT. And it doesn't involve typing. It just doesn't. It involves running and getting the output, getting and asking it to get some unit tests in. Like, no, we got to check this here. But I feel like I am creating a system more than I am coding. And, I do think that is sort of being misunderstood. There is a group of people who still want to feel like I'm going to code it all. And then there's a group, maybe I'm part of that cohort, where it says, that's not the part that I like. What I like is the system that I'm building. I like the output that it's creating. And so, maybe that means that data engineering changes a little bit, or it might mean that there's only, most people don't need to code, but some people will for some of that really hardcore nitty-gritty stuff. Do you think that, this is just blue sky thinking, but do you think ultimately that first thing I said is that, do you think a lot of coding will go away for a lot of pipelines as these LLMs and these systems around the LLMs improve?
I'll like being a bit cynical, but like a lot of pipelines don't involve code already, right? A lot of things can be done with graphical user interface, or even, is YAML code? I won't argue, but I mean, you just describe or configure things, and a lot of systems are powered by that, and it works. But there's some code somewhere, right? But the question is always like, what is the end user's experience? Because what you describe is like, the LLM can figure out the code. I'll just talk to the LLM and I get the pipeline. To me, it sounds a lot like, I'll just input the configuration in the black box like pipeline machine, and data will be on Snowflake at the end of the day, right? I think the code is incidental in the sense that it's not the output. The output is the data. The pipeline is the thing you're producing. But the code quality and the code itself is super important, because that's what the humans are able to review. So it's like, it's non-trivial, right? To me, again, coming from ML engineering, this problem is like exactly the same as you have a classifier that says it's a cat or it's a dog, but you want to know why. And you want to know why even more so when it fails, because when it's so obviously a cat for you and it says dog, you're puzzled. But with LLMs, it's like it produces code that makes no sense, and you will ask it why it did that. Well, it says, well, here it says that this, like, no, this method doesn't exist. Like, and if I was like to frame like succinctly what's happening, I think engineers need to code, need to know how to code, but I think we might read more than we write. And I think it's already the case. Like working on a big code base for open source projects, like my PRs are touching 3 files, ideally like 1 file. Like they're small, they don't change a lot of, like maybe I changed 70 rows in the like lines of code in my entire like large code base. What I do most of my day is reading code. And I think this is maybe accelerated with LLMs. Maybe you read more code. And I think when people talk about AI fatigue or some of these things, like they're tired of reading bad code. And to me, the pragmatic solution, or at least what I see as a future, is like, if you, when I ask the Claude to write me a pipeline, like I do this for like ad hoc analysis or like to quickly answer like questions, I like just give me code that I will throw away. To me, it's like it's starting from scratch. It doesn't know any framework. It uses for loops, and it just does things like with the basics of Python, right? I think a lot of the code quality is solved when the tool, like the LLM, becomes good at using the right Python libraries. So like we built DLT for humans. We built DLT to solve like complex data engineering problems like schema evolution, incremental loading, managing the resources on your machine that runs the pipeline. If the LLM is able to use DLT well, like one of the consequences of that is you have code that's readable, like just like out of the box. And so one of the things that I'm focused on, like in my day to day and what I'm building, like data quality checks. We also have like a Python library makes it easier to test your DLT pipelines and objects, like a PyTest plugin, and all of these things are to me part of this broader, like I'm engineering a system. Like I want, if you have an agent or like a machine that can build a lot of pipelines, you're able to ingest a lot more data. You're able to answer questions faster. You're able to answer more questions. You're able to have data that's more fresh. But the engineering this big machine that creates pipeline is non-trivial, and that's why like you need AI engineers.
Yeah, and I think just to kind of bring that home to me, the libraries that we use, and to your point, some of it's YAML, some of it's GUI, but we'll just say in the small data tech bubble that we're in, we like to code, we like to see the code, and I do think that's kind of what the next generation of coming up behind us is going to prefer as well. I don't know if the GUIs are quite doing it for everybody, but you don't really need the GUI if the LLM is able to make the code. Like the LLM becomes, I guess, the GUI at that point, but you get to kind of see what's underneath and you need to be fluent there. When I started with DLT, I never wrote anything. I just copied from the doc. I put it in. I looked for the next section of the doc, copied that from the doc, put it in. Yes, I updated it with the things the paths I needed to do, but then I ran it. And it just ran. And I think the documentation part is the future of actual of these projects, open source or not. Is everyone's going to have an LLM, and if your library project is going to work well with it, then you really need to focus on what your documentation looks like. You need to focus on the quality of the code at that documentation level and making sure you're filling in all the gaps to essentially allow for that documentation to be the sub prompt before they even ask anything, for the LLM itself. And that's kind of what I guess that's the conclusion I've been coming to, is that the future of making data pipelines with LLMs is really about the documentation of the libraries that we're going to be using to build those.
Yeah, I think like it's funny, like it's everyone in the company speaks docs, like whether it's people doing education, DevRel, marketing, people building features, building the platform, engaging with customers. Like we need good docs, and we need everyone to understand docs, because that's also what their users interact with. And that's also what LLMs interact with. Like there's an interesting overlap of what makes the tool better for humans and users is usually the same thing that makes it better for LLMs. Like for the LLM, I need to create like a box or an environment where it can mess up safely. But for building a good tool that LLMs will understand, it's usually the same thing as making tools that the humans will understand. And to your point, like the docs, it's something I think we had a large overall like 2 years ago. And I think a lot of the content is structured as a user guide would be. So you have a code snippet that's like very focused about what it does with explanation. We test the code to make sure that it's up to date. And the documentation is like, it exists within the DLT repository, but it's a product in and of itself. Like there's a lot of code to just produce a good documentation. Like maybe it's something like, it's obvious to me as an insider, but like if you go to a website for a project that you like and the documentation is good, like it's part of like, they have a CI/CD pipeline, they have tests, they have like, they check for the grammar and they make sure that the changes are like properly like demonstrated. They need like images, interactive elements, and it's basically like an entire product. Like it's like shipping a website. It lives and it's a product.
It totally is. It's part of the product. And from what I can tell from DLT Hub in general, there's a lot of effort going into that, into the documentation, and then also through sort of the subsequent community content built around it. So, that's just what I took from that. It was the most successful data pipeline I just sort of vibe coded before, and I thought to myself, why does it work so well? And I just started to think, yeah, it has to do with the docs. It's all about the docs. And so when you see these other libraries falling off, well, I just think it's because you're not treating your documents and your documentation itself as part of your product or as part of your library and your package in general, and you really have to.
Yeah, I think maybe to add also, one thing we measure ourselves against, like in terms of agent or a good experience for coding, is we think like Copilot, Cursor, Continue, like Cloud Code, like LLM IDs are great. They help you code. Like you don't see it maybe, but like they add, like the LLM is just string in, string out, but this IDE does add a lot of context. Like automatically it adds like, hey, the user is trying to do this, or like this is the current file that he has opened, and it adds this into the machine. And for us, like the thing we measure ourselves against when we want to like sell AI feature is like, one, like the user should be able to have a working pipeline, but the experience should be better than like the base Cursor, because Cursor like solves a lot of problems around like writing code and navigating the IDE, but it doesn't know anything about data engineering or like data pipelining or DLT specifically. And this is like in and of itself, again, it's back to the AI engineering. Like you have a big LLM, it's very smart, but you need to give it the right instructions to get the right output. And the documentation is one piece of it. We have an MCP server. We built this like new feature, like idea that we call the LLM scaffolds. So it's like text description or like a piece of context about a REST API source. So we have, I think, like more than 8,000 today, like at this date. And what it allows is people to build connectors quickly, because yes, like Cursor plus like the latest GPT or the latest Anthropic model can write DLT, but it still doesn't know anything about like your GitHub REST API source or your Algolia search endpoint. And so that's like the next step, I think, in data engineering is like, how do you like it's a product or it's a startup or it's a feature of libraries, but we need to give easy to understand information about what the systems we're interacting with are, because I can give the documentation to the LLM about DLT, but it doesn't know anything about where the data comes from or where it's going to. And so
yeah, and that's kind of what I wanted to finish off with topic wise is where can we see this go? Like, what is the blue sky perspective here? If we solve a context problem, and that not only has to do with the context window and the way that the LLM is able to handle a large amount of information, but also the documents that are created for the context to go with an LLM. How far can we kind of take that? Like right now, I'm writing DLT pipelines that move something from somewhere to somewhere else. That's really useful. But what is an entire data pipeline? Well, there's an actual data source, and maybe I want like a schema or a data contract represented there, and then I want that to come into some sort of pub sub situation of some way, and then I want it appended into source, and then I want that shipped off somewhere else. Right now I feel like it's all about coding with the LLMs. How far do you think that are you thinking that you can really take the ability to prompt something like an LLM and say, make me the pipeline? Like, what would it take to get all the way from the beginning to the end there?
It's always hard to assess how close or far you are in tech, especially with AI. But I can tell you, like, the problem I'm thinking about I think is core to the extract and load space. Extract and load, you have data in a lot of systems that your company uses. You want to push it to maybe a data warehouse, a data lake where you will do analytics, do other things. As someone that builds extract and load, I cannot know all of the sources you use. And even if I know, like, you want to ingest data from Zendesk, from HubSpot, and from GitHub, you have specific ways of using it. You care about specific sets of data. You have like your own credentials. You know how like it is used within your company. So there's always, like I call this like the last mile problem, where the end user needs to configure that. Where we're at right now, I think we're able to provide context about all of these sources, like in terms of text, for example, like it's a piece of text that says, hey, HubSpot is like this, it has this data available. Something we're working on right now and should be like available soon enough is we can ship you code. Like we can take, it doesn't make sense that all of the people that use DLT plus this other source need to like spend tokens and figure it out. Like we can just provide all of the code already, but then there's a last mile that you need to configure. And that's where you need to have like the LLM plus the DLT code base and like maybe an agent or like whatever the shape of this thing is. It needs to make it very easy for the user to configure like the last mile, right? And once you have this, like the other thing is we cannot figure out like the credentials and we cannot test 10,000 pipelines, right? Let's say I'm offering 10,000 connectors. I cannot create an account on these 10,000 system, create fake data, load data from these systems like every day to make sure nothing breaks, because these companies will change how their system work. But what I can do is like strategically is like, oh, you are one of my customer, one of my user of like this dlthub like feature. You have access to a large catalog of features. Like you tell me, oh, I'm running this connector that like, I don't know, 10 customers are using. I am hitting a problem. And hopefully like me as a connector provider, I can like in an automated way or like with the LLM, I can tune and fix that problem upstream so that I'm able to distribute code that is working incorrect. Like to me, that's the shape of the business that will be prevalent in a few years, where people distribute very large catalogs. When they're informed of things that break, they're able to fix it, because it seems that it's the most efficient. Like you could also have otherwise you as the end user would need to run the big machine that solves everything. Probably that's something that will exist also, but very abstract. Maybe I wasn't very clear, but to me, that's like the shape of where things are. It's like people will distribute code like they are right now, but they will be able to distribute way more code. Users will always have the responsibility for the last mile because they're using systems in a very specific way, and then the update rate and the possibilities to like customize things will just sharply increase, I think.
No, I think you did a great job of explaining it. The way the last mile idea, I hadn't thought of that before, and that's a really, really cool way to describe it. It's like, it's almost, there's a single binary here that we can offer you, and what's in that is all the code that you need to go from source creation to say it gets sent to a pub sub document, to say it gets appended. Like the whole thing's there. You just need to sort of, maybe you got to update some YAML file to configure that to work appropriately. And that really is, that's a much more elegant way, I think, solution of doing it. That makes a lot of sense. So Given that, do you think that we're seeing just a lot of consolidation in the data space in general? People are saying the modern data stack is dead, whatever that means, quote unquote, modern data stack. To me, that just means the last 15 years of basically data technology that seems to be coming to an head. We're at a new epoch, if it will, with what AI is doing. To get to where you're at, that describing, here's just the code distribution, you just sort of configure it. That sounds like 6 different tools all in one in my opinion there. So do you think that the consolidation of the industry is just going to happen, and we're going to collapse into the ability for a LLM, and then less number of companies being able to say, hey, we actually can build the entire pipeline for you here, as opposed to you needing to plug in a bunch of different services kind of and then stitch them all together for you to get it to actually work?
Yeah, there's a lot of things that changed, like in the global economical context and economic context, and everything is a lot of moving parts. But to me, for LLMs at least, the cat is out of the bag. So if someone thinks that there's place for competition, that's what I mean to say. It's yes, big companies are able to provide the smartest LLMs, but with DeepSeek, we saw that if you stack 4 or 5 MacBooks on top of each other and plug them in a wall, you're able to build something very powerful. So I think it's not realistic to think there will be one player. I think there's a lot of value in this AI engineering. Yes, you can have an LLM, it knows things, but then you have Cursor and it knows more things about code. And then you have maybe dlthub that knows things about your entire platform. So there's an interest for integration there, because the consolidation and integration is what gives more context to the machine, right? But I think having access to the there's always a builder, a tinkerer. I'm like this. You can stitch these systems together and use the best part of each, and use your own model and everything. So I don't know what the future will look like, but I believe that LLMs will be more deeply integrated with the operational system. Right now, I think it's we have it in our it's a code assistant. It lives in your IDE, but maybe you have an MCP that tells you if a job succeeded or failed. But I think it will get closer to the compute, the storage, and maybe that means more consolidation. Maybe it will be different offerings. Don't know, but I think LLMs are here to stay, and I encourage people to start vibe coding or trying to generate code just for fun. At least for me, I use it for ad hoc questions, hey, statistics about different things. Maybe I'm a nerd. Maybe it's just me, but it's fun when you know how to code already to be able to do much more. And I think it will allow data engineers to get more things done and provide more value, because the low level, my schema broke, how do I fix it? I think LLMs are already pretty good at doing these things. We need to trust them and have the sandbox around them.
I love it. Yeah, that's really great. And I just agree with you. I think that a lot of people are looking for an immediate satisfaction with LLMs. Oh, this is going to it's either going to make me a lot more productive or it doesn't work at all. You got to find your way with it. I think it's actually deeply personal to work with in AI in a lot of ways, and you're sort of building you're honing your own blade when it comes to that. And you have to spend time with it and figure out, you have to have patience. So yeah, big fan of everything you said there. Thierry, this has been a fantastic conversation. We went through a lot of topics I wanted to get into today. We could go, I'm sure, for 3 more hours, but we will kind of call it and wrap it up here. If people want to read more of what you have to say or hear more of what you have to say, where would you send them?
I'm most active on LinkedIn. I was writing more before. I should get back to writing. I try to interact with people that do cool stuff in data on LinkedIn. So if you're curious about what I'm reading, you'll find me there and see my comments.
Wonderful. We will get the LinkedIn in the links. We'll put, DLT is going to be there. We're going to have a bunch of information in the show description so people can find you. But Thierry Jean, thank you so much for spending some time and talking to me today. It was awesome.
Yeah, thanks you. Thank you for having me. It was great.
And thanks everyone else. Have a great day.